I want to emphasize one more time that there are lots of different ways to approach these problems. Your approach does not have to match everybody else's, but your answer should, okay? So you're doing it differently. That is 100% okay. All right, so here we go. The last thing we did the other day was we were talking about Mallory's running regimen. Now it says number goals up here at the top, and Mallory is running. I'd like to go to the back of that, where it says check your understanding. And it says we have an arithmetic sequence. And what does that mean again? What does arithmetic mean? It means we get from term to term by adding the same number. Okay? Be sure you add that the same number, because we can get the term from term to term by adding, but it's not arithmetic unless we are adding the very same number. Okay, so here's what we know. The third term is negative 30, the sixth term is negative 6, and our job is to find the common difference. Now, what do you think? This is easy. If you do this, what are you going to do? What?
Find the first term.
Okay, we can find the first term. I just remembered I have to write somebody up. Attention, I forgot. Okay. So we can find the first term. How do you want to do that? We could. It's going to be a lot of work, though, Mr. Brady. Think about this for a second. If we drew a picture of this sequence, here's the third term, fourth, fifth, and here's the sixth term. All right? We know that to get from negative 30 to negative 6, we would have to add a total of what? 24. We also know that because that's the third term and that's the sixth term, that we're taking 1, 2, 3 steps to accomplish that. So if it's taking us 3 steps, equal steps, to go a total of 24 units, then how big is each step? 8. So that way they want to know what the common difference was. It's 8. So we could do it by setting up a system of equations using our formula for each of these. But this is so much easier. Would you agree? Does that make sense to you? Okay. The 7th term of an arithmetic sequence is 18, and the common difference is negative 5. Write a rule for the nth term, so a sub n. The rule is like the equation, the formula, okay? What is the general rule for an arithmetic sequence? There are a couple of them, but the one I had on the board the other day was this one. That's the one you learned last year. So what do I know already? I know that my nth term, okay, and my common difference is negative 5. Would you agree with that? Do I know that much already? How could I find that first term?
5 times 7. Yeah. And then add that to 18.
Oh, okay. All right, let's look at this for a second. We want to be sort of careful with that, Patrick, because you're on the right track. The 7th term, well, the 7th term is negative 18. So if I let, in my formula, if I let n be 7, then this is going to be 18 equals a sub 1 minus 5 times what? No, not 7. Yeah, we're putting a 7 here, so that has to be a 7. So does that make sense to you? Yeah. So it's exactly what you were trying to do, but you want to be careful about how many sevens or how many fives you're adding. Okay, so it looks like that first term is 48. And so I can just pop up here. The nth term is 48 minus 5 times n minus 1. So I'll clean that up a little bit. 48 minus 5n plus 5. I'm getting that my nth term is 53 minus 5n. Does that look okay? I'm going to check it real quick. What should happen if I put a 7 in here? I should get 18. So 53 minus 35. Next, the graph is shown, is it arithmetic? Number 3, is this arithmetic? Yes, because why? It's linear. The slope of that is what? Oh, be careful, they changed the scale. So we're actually going up 4 and over 1. So the slope is 4. Write an expression for a sub n, the nth term of the sequence. So we're going to do exactly what we just did. What is a sub 1? Negative 6. Plus, didn't we just figure out that the common difference was 4? And minus 1. So negative 6 plus 4n minus 4. I got negative 10 plus 4n. Does that look okay for the nth term? And we could check it real easily, because if we put in like 1, we should get negative 6, and we do. And if we put in 2, we should get negative 2, and we do. Mario sets his cruise control at 68 miles an hour. Is the function that represents his total distance an arithmetic sequence? Why or why not? It is. Why?
Because it increases only by 60.
It goes, isn't every hour an extra 68 miles? So the first would be 1 comma 68, and then the second hour would be 136, and so on. It definitely is arithmetic. Very, very, very good. All right, go to the next page, back side, where it says check your understanding. Next page, back side, check your understanding. Back side, check your understanding. Write a formula for this sequence. Now, this sequence, would everybody agree, is geometric? Why, yes, because how are we getting from term to term? Multiplying by the same number, in this case, 5. So write a formula that is so easy to do. The nth term is going to be the first term, which is 2, times 5 to the n minus 1. Under no circumstances do you multiply these two numbers together. That one has an exponent, so these cannot be combined. They stay separate. 2 times 5 to the n minus 1. Okay? A sub n is geometric, and we know the fourth term is 48, and the seventh term is 384. Find the common ratio and the first term. Oh, okay. A little exciting. Sometimes it helps me, I'm real cute, to kind of look at it. So the fourth term is 48, and the seventh term is 384. the same number? Raina?
So divide 384 by 7.
Okay, so what do I, well, wait, why 7? Well, I don't know, cause it's the seventh term, is that where the 7's coming from?
Yeah, and then you just multiply.
And what would that give me if I did that?
The common ratio.
It would rain, well, actually, I don't know. No, that's not what I'm going to do. Raina, so what it means to be geometric is, we're gonna multiply by something, right? So I'm gonna multiply once, twice, 3 times to get from 48 to 384. Would you agree with that? Okay.
Do you do something with 384 and divide it by 48?
Okay, let's do that first. That sounds like a good idea.
Yeah, and then
What's the total? So 384 divided by 48 is 8, okay? So I have to multiply by the same number 3 times to cover a total multiplication of 8, right?
then you divide by 3.
Now don't divide by 3.
You multiply by 3.
No,
Isn't it the power?
so r to the third, so here's times r, times r, times r, has to be 384. But from here to here is only a multiple of 8, or a factor of 8. So r must be 2. So 48 times 2, times another 2, times another 2 should give me 384. Okay? Alright, so now I know that's 8. Alright, what's my first term?
6.
How did you get 6?
I went backwards.
Went backwards. So this one would be 24, this one would be 12, and this one would be 6. Because to go that way, we times by 2. So doesn't it make sense that going this way, we would divide by 2? Also, I want to just look at this. This is kind of special to this problem. But see how many gaps there are between these two? There's 2 gaps. Aren't there 2 gaps between the one I have and the one I want here? So if this is 8, won't this also be 8? So we could have done 48 divided by 8. It doesn't matter. It just so happens to it's evenly spaced. All right, perfect. For a given sequence, a sub 1 is 22 and a sub 2 is 33. Find a sub 3 if the sequence is arithmetic. They didn't tell us which it was. So now they're saying here's first and second term. It's arithmetic. So what's that going to be? 44, because all you're doing is adding 11. But what if it's geometric? You got the same first term, the same second term. What if it's geometric now?
Are you multiplying by 1.5?
Multiplying by 1.5. And how did you get that 1.5, Patrick?
11 is times 22 times 1.5.
Okay, so basically 33 divided by 22, my ratio here is 33 divided by 22, which is 3 halves, 1.5. So if it's geometric, it would be 49.5. Remember, the common difference is this minus this. That's how you value it. The common ratio is this divided by this. The first week of July was the opening week of the Deluxe Hotel. It had 200 guests that week. So we started with 200. In the weeks immediately following, the bookings decreased by 5%. How many guests did the hotel have in the 3rd week and the 11th week? So, start there, that's the 3rd week. I see what you're thinking, Oscar. Let's talk about this for a second. You said, okay, I'm gonna decrease 5% each week, so is that gonna be 15%? Well, keep in mind that it's not an arithmetic situation, because let's just take 100. If I take away 5%, then I'll be left with 95. If I take away 5% of 95, it isn't 90, is it? Yeah, so this is not an arithmetic situation. We're decreasing by the same percentage, but that isn't the same raw number. Would you agree with that? Okay, so it's not arithmetic, so we're throwing all that out. So it must be geometric, which means I'm multiplying. What am I multiplying by? No, not 0.05. 0.95. 0.95. Because if I multiply by 0.05, what does that tell me? How many customers I have lost. That's not what I'm interested in. I want to know how many customers I have kept. So does it make sense to you that I'm losing 5%, so I'm keeping 95%? So my formula is going to be the first term times 0.95 to the n minus 1. This will find any term I want. So to find the third term, I'll put a 3 in here and end up just taking 200 times 0.95 to the second. And then, of course, since it's a people, let's round it off to the nearest person. And then we also wanted the 11th week. Same formula, same exact thing, only now I'm taking it to the 10th. And there you go, whatever that is when you type that in on the calculator. Is that okay, everybody? All right, so now we're gonna get in our little groups again. So you 4 back there are a group, you 3 are a group, you 4 are a group, you 4 are a group, you 4 are a group, and you 3 are a group. Okay, everybody got it? So there'll be 6 groups. Yeah. All right, so here we go. We'll work on this together. Is this the AC All right, this is another 5 for 5, which means there are 5 questions.
He's like, who is it?
3 of them are going to and 2 of them are a little harder. So let's see.
I know, I don't know.
That's
We've been here.
all right, let's go.
Because it's gonna be negative here. It's gonna be negative.
Keep in mind, you can have different strategies.
Because you do a square root.
Oh, yeah.
How'd you get?
They're all the same images.
They're all.
It's easy to check your
I think what you're supposed to do is find combined.
These would be fun to keep you focused.
I'm looking for someone who has.
Oh, it's work, boys, it's work.
No trash talk.
We trash talk at the end of the answer.
That doesn't mean I know how to do it.
Yeah.
Okay, did I finish this? Oh, wait.
Divide 45 by 5.
R squared is 9. R squared equals 9. So, I got it.
So I got,
I just multiplied it. Okay, so.
what I usually do is I divide, like, I divided the 8 by the -1, and then because you have to move,
It's
to
gotta
get the a
multiply
minus
3
4, you
times.
do square root, but I didn't put the negative in the equation.
I just did make it 2 over 2. I'll get it. But the problem I'm having is. For a 5 minus 1, power 4, and the other 2 without it. Oh, okay. Yeah, okay. I see what it is.
Which one, for G? For G. -2.
I think it's, oh, wait a second.
I don't think it's because
Yeah, I can't.
Six is the second.
We're just checking.
That's what I'm gonna talk about, yes. This is easy to
Wait. Check this out.
and then it's 1, 2.
Oh, so that is the one.
That's a difference of plus 3.
Yeah, it comes out to 6 times 1.
Yeah.
Still happy birthday, bro. Really good until Friday. Oh, he makes me the day. Xander Kamara has. Did you already?
Just hang on to them, guys. We're gonna go over these in a second. We gotta give everybody a chance to get, caught up.
But even then, if you have to get it I think that is number 1 or 2. Just not
We're gonna take a couple more minutes.
Let's go D. Let's run with
You guys got it?
Oh yeah.
Oh, yeah. Okay. All right, let's hash this out. Group 1 over here.
Yeah.
What did you get for number 1? D. Raise your hand if you got D for number 1. So everybody is okay with that problem. We are good. Perfect. Okay. You guys back there. What did you get for number 2? B? Boy. How many got B for number 2? Okay, perfect. All right, how about number 3? D. How many got G for number 3? Oh, wow. Okay, now stop right there. We are 3 for 3 then. Our groups are 3 for 3, right? Okay, right there's a 3. Okay, we're good. We're so good. All right, let's see how we get on the back. Get a little harder back here. All right. What did you guys get for number 4? A? A?
Yeah,
Okay, all right. What did you guys get for that one?
D.
D? Any other D's out there? What did you guys get? Oh, you're A. You guys got A, yeah. Okay, all right, well, what did you guys get? Oh, wow. All right, let's talk about this one. Let's talk about it. So, we know we know that the 4th term and the 1st term are the same, but one of these is arithmetic and one is geometric, okay? So, I don't know what your thought process was. Okay, somebody tell me, what was your thought process here? What did you do first?
A for arithmetic.
So yeah, this was the arithmetic set. So did you say, okay, I got -1, blank, blank, 8. So I have to travel a distance of 9 in 3 equal steps. So your difference was 3? Are we all on board?
Yep.
Okay, so I want to find which was it, the 5th term? So the 5th term would be the 1st term plus the common difference times 4. Did you get 11 as the arithmetic term? So everybody got 11, even the B's? No? Okay, does this make sense to you? Okay. So now I'm going to look at my geometric setup. So I have the same scenario, only this time I have to multiply to get from here to here, right? Now, these are a little confusing, especially with the sign things going on. So here's a suggestion. Remember your formula. 1, 2, 3, this is the fourth term. So a sub 4, I'm gonna put a 4 in here. A sub 4 is 8. And it has to equal -1 times my ratio to the third. Does that make sense to you? And so -8 equals r cubed, so r has to be -2. And if r is -2, whoops, then a sub 5 will be -1 times -2 to the fourth. -2 to the fourth is 16. So this is -16. Are we making sense? So now my job is to subtract them. So 11 minus -16 is indeed 27. So my guess is you guys have got 5, -5. Somewhere in here you lost the sign, maybe with your ratio or something.
I saw it.
Okay, are we okay with that? The point is to figure it out. Funk, you got this figured out?
Got it.
Okay, all right. Last one. Who hasn't spoken yet? What'd you guys get for the last one? D? Okay, we got a D. How many got D for the last one? Well, you're flying solo, guys. But here's what I want to show you. And I talked to some groups about this, but never ever forget that when you are writing an equation and you have points given to you, it's so easy to check. So, I'm going to look at my graph, and one of the points I see clearly on the graph is 3, 4. Would you agree with that? 3, 4? So what that means is, if I put a 3 in here, I have to get 4. If that's true, then you have the right equation. If it's not true, then you don't. So, what's 3 halves squared? 3 halves to the second is 9/4. Is 9 times 9/4 4? No, wrong equation. All right? What did you guys get back there in the back?
We got B.
B, let's try B. That one is 6 times 2/3 to the n minus 2. All right, I'm gonna use my same point. So I put a 3 in here. Then I have 6 times 2/3 to the first. Well, 6 times 2/3 is 4. That's your equation. That's the
What do you think?
Listen,
Why is it that 6 is not a sub 6 is not a sub
I know the exponent, if you're using that formula, which is absolutely hunky-dory, what does your exponent have to be? N minus 1, and what is the exponent in that problem? Yeah, so when you alter that multiplier out in front, it's giving an A, when you alter that, that's gonna change your exponent, okay? So that's what makes that problem a little tricky, is you really gotta check your answer. Okay, did any group get all 5? Good job, good job. The rest of you were 4 for 5, right? Okay. Perfect, put that away. All right, we're going quickly to 2.2. We won't get this done, but I want to begin 2.2. The entire first page is just stuff, like textbook stuff. But up at the top, I want to fill in those blanks. in the last section, so on Friday, we learned that arithmetic sequences behave like linear and geometric sequences behave like exponential. Exactly. And I can't remember if I made a note on yours. I did. So I want you to make a little note. Anytime the growth factor, which is the R of an exponential or a geometric sequence, anytime the growth factor is bigger than 1, no matter where the sequences start, eventually the exponential will outgrow the linear. Exponentials are always going to win in the end if the growth factor is bigger than 1. Okay, that's just something to store in the back of your mind. Anytime R is bigger than 1, exponential's going to be the biggest. Okay? So if somebody says to you, somebody hires you and says, okay, I'm going to pay you, I don't know, I'm going to pay you $100,000, I wish. I'm going to pay you $100,000 and give you an extra $5,000 every year. Or I'm going to pay you $80,000 and give you a 7% raise every year. If you think you're going to stay at that job for a while, take the 7% because it is going to grow faster every time. Okay? All right. Example 1. Selected values of several functions are given in the table below. For each table, determine if the function could be linear, exponential, or neither, and give a reason for your answer. Now, certainly, we could plot some points and just kind of look at it, but that's not what we're doing. We want to come up with kind of a, number sense reason. So take a look there. What do you think about chart A? Notice that the x's are equally spaced. Why do you think it's linear? Isn't the rate of change the same? And if the rate of change is constant, then that is going to be a linear set of data, which means it's arithmetic, right? You could create an arithmetic sequence out of that. Perfect, good thinking. All right, what about B? It's neither linear nor exponential, but it is something. Do you remember what it is? Little review question. What are the differences? First one is 1, and then 3, and then 5, and then 7. What's happening to those? They are all increasing by a constant amount. So that means it's quadratic, exactly. This is a quadratic. So the directions were determine if it's linear, exponential, or neither. Well, it's neither of those, but it is quadratic. Do you remember that? Yeah. Okay, what about C? This one is geometric or exponential. This one's exponential because look at those differences, guys. What's your first difference? 1, and then 2, and then 4, and then 8. What's happening to those differences? Aren't they increasing by powers of, being multiplied by 2? And if you look at your y values, look at your y values. The ratio of second to first is 2. It's 2 over 1. And then 4 over 2, 8 over 4. Do you see what I'm saying? It's clearly exponential. The differences are proportional. These are all the same ratio. Beautiful. And what about D? It is also exponential or geometric because what's happening to those differences? They are being multiplied by -1/2. or 1/2, I mean, 1/2. The differences were negative, that's why I said that, but yes, they'll be multiplied by 1/2. Everybody okay? Okay. All right, example 2. While the rumor is spreading that he won 3rd place, the number of people that have heard the rumor can be modeled using a geometric sequence where the 43 people had heard the rumor on day 3, so 43 is day 3, and 140 are day 6, and it's geometric. According to the model, how many people to the nearest whole number have heard the rumor by day 10? Okay. Now, all the sequences we've looked at so far have had nice little ratios, like we're timesing by 2 or we're timesing by 3/2. That is not going to be the case with this one. So let's talk about how we can do this arithmetically, with equations and things, sort of meat and potatoes way. Would you agree with this equation? I'm looking at this data. Would you agree that 43 equals a sub 1 times r squared? Would you agree with that? Everybody should agree with that. And similarly, 140 equals a sub 1 times r to the 5th. Would you agree with that? Okay? Now, what is that? A system of equations. It's like x's and y's. And how do I solve systems of equations? Either substitute or eliminate. I think I'm going to solve for a sub 1. So let me know if that makes sense to you. I took this equation and divided by r squared, and this one and divided by r to the 5th. Does that seem okay? And then I can set them equal to each other. By the way, normally any self-respecting math teacher would be like freaking out about dividing by a variable, but why is it okay this time? Why would it not be okay? Why can I not divide by a variable? Because you don't know what it is and you're not allowed to divide by 0? Is there any chance my ratio can be 0? No, because if I were multiplying by 0, none of this would happen, right? So I'm safe. Okay, what do you want to do with this mess? Cross multiply, that sounds like a winner. What do you think now? Rainy or is good for a thought? What do you think?
Divide by r squared.
Absolutely. Again, we're allowed to do that because we know r cannot be 0. Now what? Divide by 43. And then take the cube root. Now that isn't going to be pleasant, it's going to be some hideous decimal, but I want everybody to do it, and then we're going to talk about how we're going to handle it. All right, so does everybody know 140 divided by 43? And then I always just raise to the 1 divided by 3 power, but you can also cube root on your calculator. How to cube root. if you go to math, right there in that entry, you see cube root. And you can go ahead and type in 140 divided by 43. Did you get 1.48 and some stuff? All right, so here's what we're gonna do. Because that is not the answer, we're gonna hang on to that number. So we're gonna store that. So you got STO here, we're gonna store that. And since it's R, I'm just gonna call it R. So alpha R, where's the R? The R is above the times sign. So hit store, and then alpha R, and then enter. And now when I need that number again, it's gonna be right there for me. Okay, so store, and then alpha R, you can call it whatever you want. I called it R because that's what it is in the formula. And then enter, okay? Now, I also need to know if I'm gonna use my formula, which is this, right, to find the 10th term. If I'm gonna do that, I need to know what my first term is. So let's come back over here. What did we say our first term was? 43 divided by R squared? So now I'll just do 43 divided by alpha R, I keep losing the R, squared. And what did you get for A sub 1? 19.57 whatever? Okay, now your job was to find the 10th term. So take the A that's on the screen and just times it by alpha R raised to the 9th power. Now, what'd you get? 675 point something? Okay, now this was how many people have heard the rumor? So we'll round that off and say 676. Get in the habit of storing numbers you might need later in the calculator. It can improve your accuracy, okay? All right, that's enough for now. We'll finish this up tomorrow. You guys that aren't in the course yet, would you come up here? And your iPad. Get back into your College Board account.